Hello everyone, can you guys hear me? Am I audible? Are you guys able to see me clear and loud? Can you guys quickly tell me? Hello everyone, can you guys hear me? Can you please confirm that into the chat if you're able to hear me, see me, clear me loud? Hello everyone, can you guys hear me? Am I audible? Are you guys able to see me clear and loud? Perfect, cool. So very good evening everyone. Hello everyone, can you guys hear me? Am I audible? Are you guys able to see me clear and loud? Can you guys quickly tell me? Perfect. So very good evening, everyone. We'll continue learning our data structures and algorithm journey. Sorry for the little delay. There was certain technical glitch because of which I got a little delayed. But I'm all pumped up. We'll keep on solving the problems. So in the last session that we did live, we have been solving the problems in mathematics. So we'll try to continue the journey. We'll try to solve few more interesting patterns of maths. In the process, we'll try to understand the maths of the problem. And then once we do it, we will also get to solve some interesting problems. So are you all set? Are we all ready to get started and solve more problems, people? Now the sound problem is gone. Are you able to hear me clear and loud? Supratim, is everything is clear now? Can you guys please confirm if you are able to hear me clear and loud so that we can get started? Perfect. So let's get started. So let me quickly share my screen and perfect. So the very first problem that we're going to solve today is in the previous day, we have talked about a problem statement called as finding the HCF of the two numbers. So today we'll get started with the very first problem, which is finding the LCM of two numbers. Right? What we want to do, we go and find the LCM of the two numbers. What is the LCM? LCM stands for the lowest common multiple. Right? LCM stands for the lowest common multiple. What is the meaning of the LCM? Let's say, for example, I have two numbers. For example, I have a number called as a 15 and then I have a number called as 20. If I have to go and find the LCM of 15 and 20, can you guys tell me what will be the LCM of 15 and 20 people? 15 and 20, what will be the LCM? Can you guys try to go and find it? Yes, those people who have not watched the last video, you can still continue. There is nothing who's stopping you. But I will strongly suggest that you go back and watch the video of the previous session if you have missed today's session. Okay? So now, can you guys tell me what will the LCM of 15 and 20? In order to find the LCM, what we normally do, let's say that I have a number called 15. What I'll do is that I'll go and try to find the prime factors of 15. What that means, the prime factors of 15 will be 3 into 5. Then I have 20. I will go and find the prime factors of 20. So it will be 2 into 2 into 5. Once I do this, what I normally try to do is that I go and try to find the union of these two prime factors. Union of these two prime factors. So union of this will be 3 into 5 into 2 into 2. And the value will be equals to 15 into 4, which will be equals to 60. Fair enough. So the LCM of these two numbers, the least common multiple of 15 and 20 will be the 60. 5 is the HCF, right? If I go and talk about 5, The common among these two is 5. So 5 is the HCF. So HCF value is equals to 5. And LCM, which is the least common multiple, is this value will be equals to 6. This will be the answer. Am I clear, people? एक और example लेके देखते. Let's try to take one more example. Let's say that another example is my number A is equals to 15 and B is equals to 25. Can you guys tell me what will be the LCM of this? What will be the LCM of A equals to 15 and B equals to 25? Can you guys please quickly tell me? No worries, Sohan. What will be the LCM of A equals to 15 and B equals to 25? Can you guys please quickly tell me what will be the answer of this? What will be the answer of this? So again, it's very simple. I go and take the first number A equals to 15. Now 15 I go and express in the form of a prime factor. So I'll go and say that 15 value should be equals to 3 into 5. B is equals to 25, which is equals to 5 into 5. Now if I have to go and find the HCF, if I have to go and find the HCF, I'll find the common. What is the common among these two? Common is 5. So HCF will be 5. And what will be the LCM? LCM is basically the union. If I have to go and find the LCM of this is the union. So it will be 3 into 5 into 5. So answer should be equals to 75 is the LCM. So the question says that this is what I go and do it manually. Is everyone clear? How do we find the LCM? Manually. Is everyone in the class clear around that? How do we find the LCM of the two numbers manually? Sudhanshu, Tekipaji, very nice. Is everyone clear? I see there is some technical glitch today, because of which there's a larger delay between what I'm speaking and then I'm seeing on the YouTube. Perfect. So now what we need to do is we have to solve this programmatically. We have to go and write the code for solving this problem. How I can programmatically go and solve it? What should I do so that I can programmatically go and solve this problem? So in order to solve this problem, let's try to analyze this. If I have two numbers A and the B, what is my HCF? HCF is basically the common factors, which is greatest, right? That is HCF. And what is LCM? LCM is basically the largest multiple. So if there are two numbers called A and B, normally there is an expression that A into B value should be equals to LCM of A comma B into HCF of A comma B. This is a mathematical theorem, boss. What is a mathematical theorem? If there are two numbers A and B, the product of the two numbers A and B is equals to the product of LCM of A and B and HCF of A and B. Let's try to see if that is true. So let's say that I have two numbers called as 10 and 15. Now 10 is equals to 2 into 5. 15 is equals to 3 into 5. So my HCF value will be equals to 5. LCM value will be equals to 2 into 3 into 5, which is equals to 60. Now, my hypothesis was A into B should be equals to LCM into HCF. Let's see if it is true. Left hand side, A into B will be equals to 10 into 15. LCM is equals to what? 60. HCF is how much? 5. This 10 into 50. Have I found the LCM correct? It's 2 into 5. Is this relationship coming correct? Have I done any mistake? 10 is 2 into 5, 15 is 3 into 5. HCF is coming out as the highest common factor, which is 5. This is right. LCM is 3 to the 6. It is 30. No, it's not 60. I'm done a mistake here. This is 30, right? So let me go and correct this. This should be equals to 5 into 30. So if I go and see that this right hand side value is also equals to 150, A into B is also equals to 150. So this expression A into B is equals to LCM into HCF is a right. We can see that. So in our previous problem, we know how to find the HCF. We know how to find the product. So if I have to go and find the LCM value should be equals to the product divided by HCF of A comma B. That should be our answer. So using this logic, I can go and solve the problem of finding the LCM. So let me quickly open my VS Code. And my VS Code, the last problem which we did in the last session, right? If you guys remember, the last problem which we did in the last session was GCD itself. Right, the last problem was the GCD itself. Let me increase the font. And this is how we define the GCD. Right, GCD was, this was my function that we go and define. GCD optimized. Now using this code, I'll go and try to find the LCM. So what I'll go and do is that let me go and define a function called as function. And I go and call it as LCM. I take two numbers A comma B. Okay. And then what I go and should return, the LCM should be equals to A into B divided by whatever is the GCD optimized, and I go and pass A comma B. That should be my code. I just go and copy this. Let me go and put that on my whiteboard. So this should be my code. Very simple and the sleek. The LCM of a number will be that you go and find the product of these two numbers and then find the GCD. GCD we already did in the last session. For all those people who missed the last session, I'll request you people to go back. Please watch that session and understand that how do we go and find the GCD of two numbers. Fair enough? Am I clear, people? Does it make sense? Is everyone clear till this point, people? Can we move to the next question? The first question was very simple. Can I move to the next question? Can I move to the next question, guys? Aage badhe? Let's take one interesting problem. So this was the question which was asked from me when I was joining LinkedIn, right? So when I was interviewing for LinkedIn, this was a mathematical puzzle which was asked to me, and I want you guys to give it a try. The question says that there are 100 doors. The question says that there are 100 doors. For example, there is a door 1, door 2, door 3, door 5, door 6. Like this, I have door 98, door 99, and I have door 100. The initial position of all the doors are that initially all the doors are closed. C is representing that all the doors are initially closed. Okay, this is the initial position at time t equals to 0. All the doors are initially closed. Now what happens? You start from the first door. You start from the first door. You start from the first door. And if it is closed, you make it open. And if it is open, then you make it closed. So you start from the first door and you go to every door. So you make every door open. Like this, you go open, open, open. First time. Second time, you start from the second door. And if it is open, then you make it close. And if it is closed, you make it open. So it is open, you make it close. You make it close. So you go to every second, fourth, sixth, eighth, 10th, like this you go and do, right? You make it closed. Third time, you start from the third door. And if it is open, you make it close. If it is closed, then you make it open. And like this, you keep on moving. You toggle the door. And like this, you continue doing for 100 times. You continue doing for the 100 times. What you need to go and tell me is that after 100 times, how many doors after 100 times, right? How many doors are still closed after 100 times? How many doors are still closed? I'm repeating the question again, Sarana. Please watch it very carefully. It's a very interesting problem. There are 100 doors, one after the another, right? D1, D2, D3, D4, D5 till D100. These are the 100 doors. Initially, all the door is closed, boss. Darwaja band hai. Now, all the doors are closed at time t equals to 0. Now, first when you start, the first time you go to each of the door, since it is closed, you open it. So you go to each of the door, you go door 1, door 2, door 3, door 4, till door 100 you go and you open all the door. Next time you start from the door number 2 and then you go to the door number 4, then you go to the door number 6, and in this time, if it is open, close it. If it is closed, then open it. Just flip the door. Next time, start from the door number 3 and then go to the door number 6, then go to the door number 9. And you do the same thing. If it is closed, open it. Open, then close it. Next, you go to the 4th door. Next time, you go to the 4th door, then 8th door, then 16th door. Like this, you go and repeat this exercise for 100 times. After 100 times, once you are done with it, can you guys tell me that how many doors are still closed? How many doors are still closed? Can you guys, I'm giving you 2 minutes of time to think over it and try to please solve it. Try to please solve this problem. You can also tell me the logic. So you can either tell me that how many doors are still closed or how many doors are open. Either of these things, right? You can tell me that after 100 times, which all doors are open? 99 are closed. No, Techie Paji, that's not right. See, I'm repeating the question again. Those people who have not understood it, I'm repeating the question again slowly. There are 100 doors. 100 darwaje hain. There are 100 doors. Door 1, door 2, door 3, door 4 till door 100. First time when you go to all of the doors. Since it is all closed, you open all the doors. Second time, you start from the door number 2. If it is open, close it. If it is closed, then open it. Third time, you start from the door number 3. If it is closed, you open it. Otherwise, you go and close it. This you have to repeat 100 times. Just to explain you, let's take a small case, right? Let's say that I only have door 10, door 1, door 2, door 3, door 5, door 6, door 7, door 8, door 9, and door 10. Let's say there are only 10 doors. So the initially everything is closed. Now the first time when I ran for the first time, so all the closed will be, I'll go and open all the door. I'll run and open all the door. Second time when I go, I'll go start from the second. So this open, it is open, so I make it closed. I remain, it is open, so I make it close. This is open, so I make it closed. This is open, so I make it closed. Sorry, this is even open itself. 8, open, I made it closed. This as it is. 10, I make it closed. Third time, I will start from where? Here. So this remains as it is. This is open, so I'll make it close. This remain as it is. This remain as it is. This is closed, so this became open. This remain as it is. This remain as it is. This is open, so it becomes closed, and this becomes open. Sorry, this remains as it is. Fourth time, I will start from the fourth here. So this is C, so I'll make it O. Before this, everything remains same. After this, C, O, O. This C is again divisible by 4, so I go and make it as O. And this remains C, this remains C. Fifth time, I'll start from the fifth. This is C, so I make it O. Previous this, I remain as it is. And then 0, closed, closed, closed. These is closed, I go and make it open. Next, sixth time, I'll start from the sixth. This is open, so I'll make it close. Before this does not make any change. And then it remains as it is. Seventh time, I go to the seventh. It's open, I make it close. Everything else remains same. Eighth time, I start from the eighth. I make it closed. Everything else remains as it is. Ninth time, I go to the ninth, make it closed. Everything remains as it is. Right? And then the 10th time, I go to the 10th and make it closed, and then everything remains as it is. So after 10th time, if I go and ask you, which all things remain open? So this door 1 is open, door 1 remains open, door 4 remains open, right? And door 5 remains open. Am I correct? Is it making sense? No, door 5 will also remain closed only. I think here I did the mistake. When I did the 3, this should be opened only, right? This remain open only, open, open, open. And at this fifth time, it should become closed. So this will be also closed. So typically, when I go and do this, D5 is also D4, D1 and D4. These are the only things which will remain open after this. Am I clear with you people? Is the question clear to everyone? Very nice, Amit Mandal. Are you clear with the question, guys? Are you clear? Now, let's try to think that how do we go and solve this problem? Let's try to think that how do we solve the problem? Now, if I go and talk about any door, let's say that I go and talk about any door, what we are trying to do, it is initially closed, then we are opening, then we are again closing, then we are again opening, then we are again closing. Like this, the event is happening, right? So if the door is initially closed, and if I go and do the even number of operations, if the door is initially closed, and if I do the even number of operations, then after even number of operations, will that door remain open or door remain closed? The question for you is, if initially the door is closed, and I end up doing the even number of operations on the door, will the door remain open or door remain closed? What do you guys think? Very nice, Pravansh. If I have a door which is initially closed and I do the even number of operations, open, close, open, close, open, close, like this, what will be the state? Say, for example, the door is, this is the door. it is initially closed. Now, if I do even number of operations, let's say that even number of operation is equals to 2. So I became, C becomes open and then I became closed. So if I do open, it again becomes closed. Agar if this is 4, so this is open, then closed, then open, then again closed. So when you do the even open number of operation, if it is initially closed, it will be closed only. And if I do the odd number of operations, then what will happen? It will come in the open position. Am I clear with this logic? The door is initially closed and I do the even number of operations, the door will be closed only. And if the door was initially closed and on that door, if I go and do the odd number of operations, it will end up staying open. Fair? Now, coming back to this problem, I have door 1, door 2, door 3, door 4 till door 100. Okay. First time, I am going to all the 100 doors. Second time, I am starting from second and I go to every second door. Third time, I am starting from third and I go to every third door. Fourth time, I am starting from fourth and go to every fourth door. Like this, I am continuing, right? This is how the sequence will be. Now, if I go and ask you, if let's say, for example, if I go and ask you door number 20, if I go and ask you door number 20, how many times it was flipped? Can you guys give me the answer? Can you guys tell me the door number in this whole 100 exercise, when I go and do it for 100 times, how many times door number 20 would have been flipped? Can you guys tell me the answer? Can you think of? Can you think of how many times the door 20 would have been flipped? See, door 20 would have been flipped when I was running the first time. Door 20 would have got flipped when I was running the second time. Door 20 would have got flipped when I am running for the fourth time. Door 20 would have got flipped when I am running for the 5, and door 20 would have got flipped when I am running for the 10, and door 20 would have got run when I am running for the 20. Fair enough? Does it make sense to you people? So how many times door 20 would have got flipped? 1, 2, 3, 4, 5, 6. 6 times. 6 times, no? Door 20 would have got flipped when I started with 1. Second time, because second, 4, 6. Fourth time. So all these numbers which can divide 20. So how can I find it? All the numbers which will divide 20 that many times? Right? All the divisors of 20. How many divisors of 20 are there? 1, 2, 4, 5, 10, 20. Similarly, if I go and ask you door number 60, how many times it would have been flipped? Can you guys tell me the answer? How many times door number 60 would have been flipped? So if you go and find the door number 50 to be flipped, I will consider 1, 2, 3, 4, 5, 6, 10, 15, 20, 30, and 60. Right? All these are the divisors of 60. So when first time, second time, third time, fourth time, fifth time, sixth time, 10th time, 15th time, 20th time, 30th time, 60th time. How many this is there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Am I missing anything? There should be 12th also. right? So it will be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So this will be happening how many times? 12 times. Am I clear? Does it make sense? And if it was done 12th time, door 60 will be open or close? Open or close? If I do it 100 times, door 60 was initially closed. So after 100 attempts, it will be open or closed, sir? It will be closed. So which all doors will be open? If I have to go and answer a question, which all door numbers will be open? Only door numbers will be open whose number of factors are odd. Because all those door numbers whose factors are even, they will remain closed only. Only those doors whose factors are, number of factors are odd, those doors will be open. Can you guys get this logic? Bolo dosto. Those doors whose number of factors are, those door numbers whose number of factors are odd will become the open. Who will be those door numbers? What will be those door numbers? So all the numbers which are perfect square. What is a perfect square? Square of a number, whole number. For example, if I go and take a door number called as 25, and I go and find what are the number of factors of door number 25, it will be 1, it will be 5, it will be 25. The number of factors of 25 is how much? 1, 5, 25, which is odd. So if it was initially closed, at the end it will be what? Open. Take any other number. For example, 4. 4 is a perfect square. If I go and take the number of factors, it will be 1, 2, 4, which is again odd. So when I go and flip it for the odd time, if it was initially closed, after that it will be open. So what we need to find? We need to find that from 1 to 100, which all door numbers are perfect square. If I go and find that from 1 to 100, which all door numbers are perfect square, I am done. So what will be those numbers? It will be the door number 1, then it will be 2 square, then it will be 3 square, then it will be 4 square, then it will be 5 square, then it will be 6 square, then it will be 7 square, then it will be 8 square, then it will be 9 square, and then it will be 10 square. So these are the door numbers, which means that door number 1, door number 4, door number 9, door number 16, door number 25, door number 36, door number 49, door number 64, door number 81, and door number 100 are those door numbers which will be open. Maza aaya? Is it making sense to you people? Is this point clear? This is a very beautiful problem which uses a concept. Only perfect square has even number of factors. Please note it down in your diary. This is an important concept. This could be in the interview, Guma Firake, people can go and ask you this question. Only the perfect squares has even number of factors. Everyone else, every other number in this world will have the odd number of factors. Sorry, only perfect squares, मैंने उल्टा बोल दिया, has the odd number of factors. Only the perfect squares has the odd number of factors. Every other number will have the even number of factors. So if I have to go and find all the open door numbers, what I need to do? I just need to go and print these numbers. So let's quickly go and write the code for this. How do I go and write the code for this? So I'll go and open my code, and let me go and comment out all these codes which we have written previously. Guys, as we are doing it, let me do a quick announcement. So in our live session description, you will find a WhatsApp community link. Please join that. Please join that. And why should you join it? When you join it, all the materials of this session, like notes, like the code that I have written, and I want to take it a step further. I want to do it as if it is a paid course only. So I would also give you the assignments, practice problems, and also the solution to those practice problems. So if you want to make sure that you want to make the best out of this course with the proper continuity, please join that community. और इतना अगर मेहनत कर रहा हूं तो मैं आप लोगों से in return I'm only expecting that you try to go and bring 10 more friends of yours. Go and tell your school colleagues, college friends, juniors, seniors. Let's say to make this the biggest community of the JavaScript. Fair? So now coming back to the code, let me go and write the code for this problem. So my VS Code, where is that? It is here. So I go and define a function, and I go and call it as print door, print open doors, right? And then the number is num, how many doors that I want to go and do it. Okay, so what I'm going to do is that for I, and then for I equals to 1, I is less than 100. Or I can go and say that, for I is less than 100. That's perfectly fine. I plus plus. Or I think it's better that, I can go and write a while loop here. So I go and say that let I is equals to 1 while I is less than 100. What I go and do that, I go and print this console.log. I print I. And then what I go and do that, I go and say that I into I. Equals to 100. And I go and do this I plus plus. Correct. And this should be my answer. This should go and print me all the open doors. If I go and copy this here, this should be my this is a simple code. So if I go and try to do the dry run, right? So in the very beginning, when I'm starting, I value is equals to 1. 1 is less than equals to 100. So what will happen? This will go and print 1. Then this becomes equals to 2. So 2 into 2, 4 is less than 100. So I go and print 4. Then it becomes 3. So it becomes 9. 9 is less than 100. So it goes and prints 9. Then it becomes 4. It becomes 16 is less than 100. So it goes and prints 16. Then it becomes 5. 25 is less than 100. So it goes and prints 25. Then it becomes 6. 36 is less than 100. So it goes and prints 36. Then it becomes 7. 49 is less than 100. So it prints 49. Then it is 8. 64 is less than 100, so it prints 64. Then it becomes 9. 81 is less than 100, so it prints 81. Then it becomes 100. 100 is less than equals to 100, prints 100. And after that, it becomes 121, and this breaks. So these are the doors which will be open. These are the doors which will be open. Am I clear, people? Now, a common question which the people have said that a common question. Sometime you go and make use of for loop, and sometime we normally go and make use of while loop. How do I decide that when should I go for the for loop, when I should go for the while loop? Now, there's no much great difference. Ideally, everything that you can do with the for can be done with the while also. But one thing which I normally follow, the approach is, when you know how many times the loop is running, when you know the fixed number of times that I want to go and run for 10 times, I want to go and run for 100 times, I want to run for 121 times, when you know the number of times, go with the for loop. When you're trying to run the loop based on the condition, you're not sure how many times I want to run it. It's based on condition. Till the time the condition is there, I keep on running. Till the time C is telling me that I'll come on a date, I'll keep on trying, right? So in that case, if the condition is maintained, then I go and make use of while. So based on the condition, I make use of while loop. If it is number of times I know in the beginning, I go and make use of for loop. Exactly, Ravi Yadav, absolutely correct. Now let's try to move to the next question. The next question is very interesting, and there are a lot of problems which comes in the market from this concept. What is that next concept? The next question concept is called as concept of a prime number. Right? So first of all, let's define that what is a prime number. A prime number is a number which is only divisible by 1 or that number itself. What is a prime number? Prime number is a number which can only be divisible by 1 or the number itself. For example, 11. 11 is a prime number because it can either be divided by 11 or 1. 7 is a prime number because it could be only divided by 1 or this 7. On the other hand, if I go and talk about 6, 6 can be divided by 1, it can be divided by 2, it could be divided by 3, it could be divided by 7. So it can be divided by more than 1 and 6. So it is not a prime number. Am I clear, people? Am I clear? Is everyone clear what is a prime number? A prime number is a number which can only be divisible by either the number itself or it could be divided by 1. That's the whole concept. You cannot have a prime number which is divisible by more than 2 numbers, right? So first concept of the prime number is that every prime number is divisible by only either 1 or the number itself. Fair enough? Am I clear, people? Does it make sense? Is this point clear to everyone here in the class? Am I clear, guys? Bolo. Okay. Now, few of the facts. If I go and talk about 1, see all the numbers 1, 2, 3, 4, 5, 6, 7, 8, 9, like this, if I go and talk about, in this 1 is neither prime nor composite. So all the other number, for example, 4, which is equals to 1 into 2 into 4, these are the factors. These are termed as the composite numbers. Right? Those number 5 are considered as the prime number because it only have 1 in the family. This is a prime number. But 1 is a special number which is neither prime nor composite. 1 is not considered as a prime or a composite number. Okay? This is a basic maths concept which you would have studied in the school. I just wanted to give the quick revision. A question for you people. Another interesting fact about the prime number is that 2 is the only prime number which is even. There is no other prime number in the world which is even. The only prime number which is even is 2. Only prime number even is 2. Okay. So now the question comes. The question comes that you have been given a number n. It says that, dude, I have given you a number n. You have to go and tell me, is n a even number? The question is, given a number n, can you come and tell me if n is a even number? Given a number n, if n is an even number, how do I go and find it? Let's say that I have a number which has been given to me, for example, 28. Just to check if this number is a even number, sorry, not an even number, prime number. Yeah, what has happened to me? Is a prime number. To check if a number is a prime number or not, one of the most basic way that I can do is, I can start checking. First of all, I go and check with 2. If I go able to go and divide by 2, I go and say that 28 is divisible by 2, so it's not a prime number. Let's take another number called as 23. I want to go and check if 23 is a prime number or not. So what I'll go and do and check with 2. If I'm able to divide by 2, no. I'll check with 3. No, I'll go and check with 4, 5, 6, 7, 8, 9, 10, 11, 12. None of them are able to divide it. 14, no. 15, no. 16, no. 17, no. 18, no. 19, no. 20, no. 21, no. 22, no. 23, yes. So I'm able to divide with 1 and I'm able to divide only with 23. So 23 turns out to be a prime number. So this is one of the most basic way or the rudimentary way of finding if this number is a prime number or not. Can you guys write a code for this? Exactly, Samrin. Perfectly fine. Fair enough, people. Right? So, can you guys tell me what should be the code logic for this? Let me go and write the code, and you should also try in the parallel that how we go and write the code for this. So I'll go and open my Eclipse, not Eclipse, code, because I've been writing things in the code. And now what I'm going to do is, let me go and comment this out. And then I go and write here as function, and then I go and find that is prime. This number. If number is equals to 0 or number is equals to 1, in that case, this is not prime, boss. So I go and return false. If number is equals to 2, it means that it is a prime number. So I go and return true because 2 is a prime number. Otherwise, what I go and do is for I equals to 2, I value is less than equals to n I plus plus. If I find a number which can divide this n, if n ampersand I is equals to 0, then I go and return false. Else, after the for loop, if I'm not returning the false, I go and return true. Right? This is the whole logic of writing the print number. If you go and copy paste this and put that on my blackboard. This is how it is looking. So if I go and define this as is prime, and the value is, say, for example, 10. So n value is 10. n value is 10, does not hold true. I come here, n value is 10, not hold true, come here. I value is equals to 2, n value is equals to 10, 10 ampersand, 2 is equals to 0, true. So this will return that no, it is not a prime number. Let's try to run it for another test case, which is prime, and I go and check the value as 7. Right? So n value is equals to 7. N is 7, n is 7, does not hold true, does not hold true, I come here. N value is equals to 7, does not hold true, I come here. I try to go and divide. First, the I value is equals to 2. This does not hold true, again comes back. Then I value is equals to 3. 7% 3 does not hold true, again goes back. I value is equals to 4. 7% 4 does not hold true. Then 5. 7% 5 does not hold true. I equals to 7% does not hold. So this whole for loop is done. I does not return anything. So I go and return 2. So this returns out as 2. So this is a very basic code that I have written for finding if the number is prime or not. What will be the time complexity of this code, sir? Can you guys tell me what should be the time complexity of this code? What would be the time complexity of this code, sir? The time complexity here will be depending on n, that many times the for loop is running, the time complexity will be equals to order of n itself, which is the linear. If you go and solve this problem for the basic companies, for the startups, low startups, they will be happy, okay. They will say that, okay, good, you have been able to write the code. But if you're aiming to target the FANG companies and you go and show this code, they will say that you need to work better. So I need to go and optimize this code. I need to go and optimize this code. If I have to get into the FANG companies, MANG companies, I have to go and optimize this code. How I go and do it? Very nice, Avatar. So time complexity finding is not tough. Let me quickly tell you how to find. I know for those people who are finding tough to find the time complexity, a quick refresher I'm giving you, and you should go and watch the time complexity wala session. What was the time complexity? The definition of the time complexity, how the number of operations are proportional to the input size. This is the time complexity definition. You should definitely go and watch that session. Now, if I go and take the example of this code, let me go and paste the code itself here again. What is my input size here? What is my input size? N is the input size. What is the operation? Number of operation is the number of times the loop runs. How many times the loop will run? The loop will run is equals to number of operations. And how many times the loop is running? Number of operations is running n times. So the time complexity will be kya? Order of n. Fair enough. This is how we go and do it. All those people who was feeling clueless, the first video on my this channel, Vishwa Mohan, you'll go and find the time complexity wala. Time complexity. I have very detailed way. I have explained all the possible cases. Please go and watch this time complexity video, which will help you get clarified. I'll strongly suggesting all of you people who is actually interested in the data structures and algorithm, make sure that you're not missing this concept. Please go and watch that. Fair enough. Am I clear? Does it make sense? See, some of you is asking that can I go and write this code recursively? If I see, okay. So if I have to go and recursively makes sense in the sense when you have a repeat calculations. Now you can actually go and write this code recursively, but this question does not make sense to be solved recursively because there's no repeat pattern as such. Now coming back to the code which is there in my hand, right? Its time complexity is order of n, which is not great. My interviewer is saying that optimize this, optimize this. How can I optimize? Optimize means this loop which I'm seeing here, its number of loops or iteration should be reduced. The number of iterations should be reduced in this case. I should not go and run for the n times. If I have to optimize it, I'll have to reduce it for the n times. How can I do it? Sir, if you have any number num, and let's say num is equals to the product of two numbers a and b. If I have any number num which is equals to the product of two numbers a into b, if first number is greater than square root of this number, then b has to be less than the square root of a number. Do you guys agree with me? If there's a number which could be represented in the form of the product of two numbers a and the b, and if a is more than the square root of the number, the another number b has to be less than the square root of the number. Does it make sense to you guys? Fair, right? Because if a and b both are equal, then it should be equal to the number. So what this means is that if I have a number n, and if I can from the 2 till square it, if I start from 2, and go till square root of n, I don't find a divisor, then there is no divisor. If I start from the 2 and go till square root of n, see any number n is a into b. If a is less than square root of n, then b has to be more than the square root of n. So till square root of n, if I don't find any number, so if I don't find any number which is less than square root of n, it means there is no number also available more than square root of n. What I mean to say is from here that if no divisor is present till square root of n, then there will be no divisor present till square root plus 1 till n also. Is this point making sense? See, I'm again trying to explain. See, let's say that I have a number n. Okay, no? N could be always expressed as a multiple of a into b. Okay, no? There are to be two scenarios. A value is equals to root n and b value is equals to root square root n. Then this becomes equals to a into b equals to n. This could be case 1. Or the other case could be that one value, a value is more than square root of n, and then b value should be less than equal to square root of n. Because if it is a little more, then it has to be little less. Correct? So now, based on this condition, I'm trying to say that, let's say there is a number n. If we start from 2, 3, and I go till square root of n, and till this point, I find no number which can divide n, then in that case, from square root n plus 1 till n, there will be no divisors as well. Does this point make sense to you people? Batao. Is it making sense to you guys? How many of you have understood this concept? Is this point making sense? Guys, tell me. Are you guys getting this point? Let's try to take with an example. Okay. So, for example, I have 6. Right? If I go and take the square root of 16, this value will be equals to 4. So if I start from the 2 and I go, if I start from 2, 3, 4, 5, start from 2 and I go till 4, I go and see that there are multiples. 2 is a multiple, 3 is not a multiple, and 4 is a multiple. So when I have a multiple in less than 4, after the 4, like 5, right, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So when if I have less than square root 4, I have the value. I will have also after that, because after that, if it is, then it will be 8 will be the one, 16 will be the another one. But on the other hand, if I go and talk about a number like 17, right? The square root of 17 will be 4 point something, 4.13, something of that sort. Let's assume that. Okay. So numbers which is less than 4.13 is 1, 2, 3, 4. Right? And this is my 4.13. Now I have to start from the 2 itself. Now since 2, if I try to go and divide by 17, not possible. Can I divide 17 by 3? Not possible. I divide 17 by 4, not possible. So if I'm not able to divide by any number less than root 17, after these numbers will also, I'll not find a single number. 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. I will not be able to find any of these numbers from here till here also. This is what this statement is trying to say. Am I clear, Sohan? So what this condition is trying to say is that the previous code that I have written, the previous code which I have written, which if I go and paste it here in this case, I have run the loop till square root of n. I can go and actually optimize and run this root only till square root of n, and then also I should get the correct result. Because if I can't find a number which is less than the square root of n and can divide the n, I know that it is a prime number. Right? So either I can do this, or I can, so what I can do is that I can go and write something like this. I can go and say that code, and I can just make changes here. I can say that I square is less than equals to n. I square is less than equals to n. This is the more optimized code. This is the more optimized code. So the optimized code of this version will look something like this. So what will be the time complexity of this? What will be the time complexity? The time complexity of this is that, what is time complexity? Is the number of operations is proportional to input size. This is the time complexity definition. This is my input size. Number of operation is how many times this loop executes, right? So let's say that this loop executes k times. Let's assume that loop executes k times. So when the loop is terminating, I'll go and say that k square will be proportional to n. So I can go and say that k is proportional to the square root of n. K is my number of operations, and n is my input size. right? So the time complexity of this problem will become equals to order of square root of n. So the time complexity of this optimized solution is order of square root of n. And this code will help you understand if the even number is prime number or it is not a prime number. Is everyone clear, people? Does it make sense? This is a very important concept. I have seen mostly the people who are doing coding for the first time, they struggle to understand this concept. This is the beauty of YouTube. You can always go back, replay the questions and solve it. Right? So आप लोगों को, everyone who have understood this, pat your back. Can you please put that into the comments? Who all of you have been able to understand this? If not, there's nothing wrong in it. 70% of the students that I have taught for the first time, they have not been able to get this contest. But most of them have been able to go through the Google interview and crack it, provided they have been consistent. Okay? So even if you're not able to solve it, you don't have to feel demotivated. You're just getting started. But make sure that you watch it 10 times if it is needed, but your concept is getting crystal clear. Am I clear, people? Does it make sense? Sohan, absolutely right. Is everyone clear till this point? Can I move to the next question? The next question becomes at the top of the previous question, right? The next question says that if I give you a number n, if I give you the number n, what do you need to do? You need to go and print all the prime numbers smaller than n. The next question says that if I give you a number n, for example, I gave you a number called as 10. I gave you a number as a 10. What do you need to do? You have to go and print all the numbers, right? Let me write the problem statement. So the question is print all the numbers, all the prime numbers smaller than the given number. Print all the prime numbers smaller than the given number. So for example, if I give you the number 10, all the prime numbers smaller than 10 are, which are those prime numbers? So the value will be 2, 3, 5, and 7. If I go and say that the number is 20, all the prime numbers smaller than 20 will be 2, 3, 5, 7, 11, 13, 17, 19. For a human brain, which is very smart, this looks very simple. But I have to find an algorithm so that I can go and print it. I have to go and find the algorithm to print it. Am I clear with the question? Guys and girls, ladies and gentlemen, are you guys clear with the problem statement? Guys, are you feeling energetic? Can I continue this live sessions? Just 1 hour. I still have energy left to keep on going for a few more hours. Let me know if you guys are feeling good and maza aa raha hai, and we can continue solving the problems. So one of the naive approach, right? One of the naive approach said that I have to go and print all the prime numbers less than 10. Right? If I have to go and print all the prime numbers less than 10. See, one of the naive approach, see, you should always try to come up with some approach. It's okay to start with a very basic naive approach, but your first approach should be, I should be able to solve the problem. So if I try to think humanly, what should I try? One approach which is hitting my mind right now is that if I have to go and find all the prime number less than 10, what I can do is that I can start with the numbers. For example, I first start with the number 1. And then I say that, okay, I go and check if it is prime. And then it says it's not a prime number. Then I come with the number 2. I go and check for the prime and the number is prime, so I go and print 2. Then I come with the number 3. I go and check if it is prime, the number is prime, so I go and print 3. I come to the number 4, I check if the number is prime, I get no, so I don't print the number 4. Then I print 5, then I come to 5, I check the number if it is prime, yes it is prime, so I go and print 5. I come to the number 6, I check if it is prime, yes, this is not prime, so I don't go and print it. I come to the number 7, I check if it is the prime, yes it is the prime, so I go and print 7. I come to the number 8, I check if it is a prime, it's not a prime. I come to the number 9, I check if it is a number prime, no it's not the prime. So all the numbers less than 10, what are those prime numbers? It is 2, 3, 5, 7. So I'm able to print it. This is the basic approach of printing all the prime numbers. This will be the basic approach of printing all the prime numbers. Right? And what will be the pseudo code for it? So the code should look something like this. Function. Let me write the code in here and I'll put it up here. If I go and write with this approach, let me go and open my code. And function print primes. And I go and say that n for for I equals to 2, I is less than n, I plus plus. And then I go and say that if is prime, and I go and pass this number I, and if it is this, then I go and console.log, and then I go and write I. Like this, I go and write the code. So this will be my code, the logic which I just talked about. The code looks something like this. Fair enough. This is the first version of the code, version 1. This is the version 1. And what will be the time complexity of this? I know that this is gonna run for n times. And this is prime has a time complexity of at least square root of n. So this overall time complexity of this problem becomes equals to order of n square root of n. The overall time complexity is order of n root n. Fair enough, guys. Does it make sense to you people? The overall time complexity is order of n root n. Fair enough? Yes, I'm just checking in the left so that I know that what you guys are doing. Perfectly fine. And root n. Perfect. What is the more optimized solution of this? What is the more optimized solution of this? So more optimized solution of this is as an algorithm. And I'm not expecting you people to know this. So you have to just know this algorithm, take a notebook, note it there, write it down, because that will help you find this, print this prime number less than n in a very optimized manner. Right? That theorem is called as sieve of Eratosthenes. Eratosthenes. I might would have done some spelling mistake because this is a very tongue twister name. So if I have done it, please don't mind. You can go and check on the internet the exact spelling of it, but it's called sieve of Eratosthenes. Right? It is an algorithm which tells us how to find the prime numbers less than n in an efficient way, right? How do we do it? Let's get started. So what we do in this case is, let's say that n is equals to 10. So first of all, what we do, we keep a array of the number 10. So we go and say that 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And we always start from the 2. So first we start from the 2. So we start from the 2, and all numbers which is divisible by 2 and greater than square of 2, which is equals to 4. So all the numbers which is divisible by, so the first number is 2. So a number which is divisible by 2 and also it is greater than square of 2. All those numbers I have to go and cut. So what I go and do is that I go and cut 4, I go and cut 6, I go and cut 8, and I go and 10. Then I move to the right and find the first number which is not cut. So the first number which is not cut is 3. So I go and say that all the numbers which is divisible by 3 and which is greater than equals to the square of 3. So which is divisible by 3 and greater than equal to the square of 3, which is equals to 9. So I go and cut the 9. Then I go and try to find the next number which is uncut, which is 5. So all the numbers which is divisible by 5 and is greater than equals to the square of 5. So anything number which is divisible by 5 and greater than 5 is not present, so I don't do anything. The next available number is 7. So again, all the numbers which is divisible by 7 and is greater than equals to the square of 7. Nothing, so I don't do anything. Then I don't find any numbers. Once I'm done with it, all the numbers starting from the 2, all the numbers which are uncut. What are those numbers which are uncut? 2 is uncut, 3 is uncut, 5 is uncut, and 7 is uncut. All these uncut numbers, these will be the prime numbers. These will be the prime numbers. Let's take with the help of another example. Let's say that n is equals to 20. What we go and do, we can go and take an array and we go and put the number as 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. And then I have 14, 15, 16, 17, 18, 19, and then I have 20. I start with 2. All the number which is divisible by 2 and greater than square of 2. So I go and cut 4, I go and cut 6, I go and cut 8, 10, 12, 14, 16, 18, 20. Then I come to the 3, anything which is divisible by 3 and greater than equals to square of 3. So I go and cut 9, I go and cut 12 is already cut, 15 will be cut, 18 is already cut. I come to the 4, greater than 4 and greater than equals to 4 square. Divisible by 4 and greater than equals to 4 square. Not 4, it will be 5. No, next available number is 5. Actually, I did a mistake. After 3, the next available number is 5. So it has to be divisible by 5 and it should be greater than equals to 5 square. So I come and I don't find anything which is greater than 5 square. So I just leave it. Then I come 6, divisible by 6 and greater than equals to 6 square. I don't find any numbers which is same thing is true for the 7. Divisible by 7 and greater than equals to 7 square. Nothing I go and find. Then next available is 11. So it should be available divisible by 11 and greater than equals to 11 square. I don't find any number that has to be cut. The next available is 13. Same thing I do with the 13, divisible by 13 and greater than equals to 13 square. I don't find anything. Then I go and find 17 divided by 7 and greater than equals to 17 square. I don't find anything. I don't do anything. Then I do the same thing for the 19th and greater than equals to 19 square. I don't find anything. In this list, I go and find what are the numbers starting from the 2, which is uncut. 2, 3, 5, 7, 11, 13, 17, 19. So these are all the examples of the prime numbers. These are all the examples of prime number. Fair enough. Am I clear, people? Does it make sense? Is everyone clear? Now what I need to do is I have to go and convert that into the form of the code. So this sieve of Eratosthenes, I have to go and convert this into the code. I want to go and convert that into the code. How do I do it? So in order to convert that into the code, what I do is, let's say to write a logical code. So what I do is, if you can define a array first. Let's say that I'm trying to do it for the n is equal to 10. So in the very beginning, I go and define a Boolean array where I go and put the values as true, true. And we're going to represent the true with the help of the title T, 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 T. And I go and put the 0, 1, 2, 3, 5, 6, 7, 8, 9, and 10. Okay, this is my array. This is the beginning. Now what I need to do is the same approach, right? I start from here. I start from here for the first. I start from here. And then typically what I do is, if this value is true, if this value is true, then for the powers of 2, so for this 4, I'll go and make it as false in this iteration. I'll come here, I'll make it false, then I'll go and make it at 6, and I'll go and make it as false. I'll go to this 8 and I'll make it false, and I'll give to the 10 and I'll make it false. Okay, the next iteration is the next available 2, which is this. I come from here and I go to the the next is 9 typically, right? So I'll start from here, I go directly to this 9, and this value I go and make it false, and then I stop it here. Then the next 2 that I look for is this one. So I start from here, and then I see that 5 square is nothing, so I just go there and I cannot do anything, right? Next that I available that I go and see is this 7, and then again I cannot do anything, right? So once this whole loop activity is done, this array is left with the following. The array has been changed to this true, 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 false, true, false, true, false, false, false. And if I go and put the index, it's 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now we need to go and find that from the second index, from this point to this point, all those indexes where the value is equals to true, so I come here, this value is true, so I go and print 2. Then I come here, the value is true, so I go and print 3. I force, I don't do it. I come here 5, I go and print 5. I come here 6, I don't do anything. I come here 7, I go and print 7. I come here, I don't do anything. I come here, I don't do anything. I come here, I don't do it. So I go and print 2, 3, 5, 7, which is a prime number. And this is the sieve of Eratosthenes algorithm, which is popularly known. The people who do the competitive programming, they sound to be very techy, right? When they use these terms like thief of Eratosthenes algorithm, right? So I believe you guys are aware now. Let's quickly go and write the code for this, which will make things pretty simple for us. Array size will be the size, if n is equal to 10, then I have to take the array of the same size n. Now let's quickly go to my code and we'll try to write the code for it. So let me go to my VS Code. And the VS Code, let me go and define another function. Function print prime, and this is sieve of Eratosthenes algorithm. So I have to know. So basically, what this function does, this function tries to print all the prints. This function typically what will try to do? This function will print all the prime numbers less than equals to. Very first step that we need to do, we need to go and define a array. And in this array, let me go and put the values. So first of all, I will initialize it for I equals to 0, I is less than equals to n, I plus plus. And in this, I want to set that prime, and then I want to set the value I is equals to, and I set the initial value as true itself. So this is I go and initialize the array. After initializing the array, I have to start from 2. So I go and write for p equals to second index, and then p into p is less than n, less than equals to n, and then I have to go and write I plus plus. This we have already seen that we only need to go and check till the square root of the size. And I go and write if prime p is equals to true, in that case, what should I go and do? I should go and set that for, and I'll start with I equals to p into p. I value is less than equals to n, I plus plus. And I go and say that prime I equals to false. Now, once it is done, typically, I'll go and write another for loop for I equals to 2, I is less than equals to n, I plus plus. And I go and write that if prime I is true, in that case, I can go and say that console.log I. This is the entire code that we have written for printing all the prime numbers. Let me go and copy paste this. And paste it here. Okay. So this is a question, right? Let's say that I go and call this function like this. Print prime SOE, and let's say this value is 10. As soon as I go ahead, what first of all, what will do? I go and do this. When I go and execute these 2 lines of the code, it has created a prime array, which looks something like this: true, 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 true. And it is starting from 0, 1, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. I have to take one more. So I have to do it of the size 11. There will be one more t, which will be at the index 10. So this, till this, I have written the code. Fair enough. Now, in this for loop, the p starts from here. The p starts from here. And it is saying that I should only go and check till the square root of the n, right? So ideally, if it is 10, then square root of 10 will be equals to 3 point something. So I should only go and check. I only need to go and check till this point. Right? I don't need to go beyond that. Fair enough. So I first of all come with this p equals to 2. I am here, p equals to 2. Now at this point, this p is equals to 2 and this value is definitely 2. So I come inside this if block and this for loop, right? This for loop starts from I equals to p square. So this for loop starts from the I equals to 4. So I start from here, this point. And if this is the case, I have to go and set this value as false. So I go and set this value as the false. Then I go to the this should be equals to I equals to not I plus plus. It should be I equals to I plus P. It should be okay. So I come here and then I should go to the C. I go and do this, and then I go to the 8, and then I go and do this. Fair enough. Once it is done, then I again run the second iteration. The P value now becomes equals to 3. Right? So I'm still fine. So I'm here now. Right? And since this is also equals to 2, so I go inside this. So P is equal to 9. So I directly start from 9 here. Since it is 2, I make it false. And after this, it goes. Once I move further, this becomes equals to 4. And the 4 square is, so this loop is also done. So once I'm done with this for loop, the above array, which is the prime, looks something like this: true, 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 false, true, false, true, false, false. Right? So in this whole reason, P. This is what the code should be look like. Right? So this is the code that we have written for the print of sieve of. Cool. So this is the code. I hope all of you are clear. What I'll do now is that I'll try to stop here because we have solved a lot of problems. There's a lot of concept that we have covered. My request to all you people who is watching this session, please make sure that after this session you are revising it. If needed, you have to watch it. What is for 3 times, 5 times. But make sure that the concept is inside you. Your concept of prime, what is the prime number? The concept which I use, that I should, when I'm trying to find the prime number, I should only go till the square root of n. Why is that? Right? This concept, this whole logic of finding the prime numbers less than n, this whole algorithm, I want you people to master that. Once you have understood, try to write the code for it, and then, just for the accountability, tag me. What I'm planning to do is that once this session is completed, tomorrow morning, if you guys are already added to this community, you will get the notes. That's number 1. And then you will also get some kind of a practice problem, boss. And with the practice problem, I'll also provide you the solutions of that. So that not only we do it on the YouTube, you also get enough assignments so that you can do the proper pakka wala practice. Only thing that I expect is a little sincerity. If you are honest to your work, trust me, I'll make sure that you guys are doing everything, all the concepts, all the questions which is needed for the companies like a FANG also. Cool. Can I expect that little sincerity from you people? And if yes, then I promise you that every day, no matter what happens, I'll try to make my best to make these live sessions count, right? It should be as better than any other lakhs rupees paid courses. Perfect. So thank you everyone for joining me. It was really enjoying. After the whole day, when I still get to teach, I think that's the biggest kick which I get in the day. So all this I'm doing is just for my passion of the teaching. I love teaching. I love connecting to you people. When you write comments, when you tag me, when you share the screen, trust me, I think that's the biggest kick and the motivation and the happiness for the entire day. So keep maintaining the love. Please share the channel with your friends. I need your support definitely, and I don't want to shy away from it. I need you people help, support, love, so that I'm motivated enough that more number of people are coming live, they're watching these sessions, and I continue doing this for years. My whole target is that we are starting with JavaScript, DSA. Once it is done, then we go and talk about advanced JS. Then we talk about the backend development. Then we talk about the front-end development. Then we talk about the TypeScript. Then we talked about the Next.js, right? Then we talk about every advanced feature of JS. So this is around the JS stack. And for those friends of yours who are interested in the field of data science, I want to start a data science series as well on this channel from the scratch. So once I see enough motivation from the people, enough hustle and bustle, I would like to get started with the data science itself, where we get started with something called as a Python. Then from the Python, we go and talk about the DSA in the Python. Then we go and do the development in Python. Then we do the statistics in Python. Then we go and do the machine learning. Then we go and do the deep learning. Then we go and do the generative AI. Right? We'll try to complete the entire stack of data science. And for all those people who are in the first year of engineering, who are going to take the admissions, I'm planning to add few, the basic computer fundamental concept. For example, C programming language, BBMS, networking, operating system. All of this will be present on both my Hindi channel as well as the English channel. On Hindi channel, I've already started our Java batch. The name of the Hindi channel is Coding Shala. The name of the Hindi channel is Coding Shala. So tomorrow, alternate days, one day I'm coming live on our English channel, teaching JavaScript with JS. Other day I'm coming live on our English channel, I'm teaching Java there. So that's all people. Thank you everyone. Thanks for joining me. I'll see you more. Keep supporting and keep learning. I want you guys to make the best out of it and try to be the top 1% techies. Thank you everyone. Good night. Take care. I'll see you more. Bye.